On this lesson three, we are going to talk about factorials and how they relate to the calculation of probabilities. Now, if you are watching this before my lesson about factorials in Pure Math 1, and you probably are, because that's the last chapter that I teach in Pure Math 1, you can always check it in any of my access tiers if you want to complement this lesson and learn a little bit more about factorials. But the chances is that you are listening and you are hearing about this term for the first time right now. Okay? Again, at the end of this lesson, you should know what a factorial is. It's actually a very simple thing that you can get using your calculator. But there's more to it that you can always look at in Pure Math in last chapter. In order to talk about that, I'm going to go over this situation that I'm describing over here. So imagine that you have 4 whiteboard markers with different colors: black, blue, red, and green. You don't need to imagine because I have them. Okay? So let's say that these are inside a box. Okay, now I don't have the box. You just have to imagine that. What's the probability of getting them out of the box in this exact order: black, blue, red, and green? What is the probability that this is the exact order that I take them out of the box? So you know that the probability is the number of possible events divided by the number of the number of relevant events divided by the number of all possible events. So we are talking about one specific order, okay? So you have one out of how many different situations, how many combinations could you have if you would take the 4 markers out of the box? Let's start with the black. What is the probability that you have the black as the first one coming out of the box? So you have 1 out of 4, so you have 1/4, right? So this one is already taken. Now, which one you want next? You want the blue. So what is the probability that you have the blue? It's 1 out of 3, okay? So 1/3. What is the probability that now you have the red? It's 1/2, right? And the probability that you have the green, that's certain. So you have the probability 1 over there. So if you would build a probability tree, you would have 4 columns. What would be the probability of the combined events? It would be the multiplication of all these 4, right? As we saw before. So it would be 1/4 times 1/3 times 1/2 times 1, or just 1 over 1. You can make this as a single fraction. That is going to be 1 divided by 4 times 3 times 2 times 1. Now, what is a factorial? A factorial, represented by exclamation mark. The factorial of 4, for example, is just represented by that, and is just 4 times 3 times 2 times 1, which is 24. And you can get it in your calculator. In a calculator, give me a second, I'm going to get one. Sorry for this. In a calculator, you have a key. Actually, it's not a key. It should be on top of a key. Where is in this one? I'm without my glasses, so I cannot see very well. I just used it a little while ago, and I can't remember where it is. Well, I need my glasses. Anyway, it's usually on top of one of these keys. On your own, you just have to look at it. And then how do you use it? In this particular case, you just press 4, then Shift, and you press the key for the factorial, Enter or equal or whatever, and you have the result, which in this case would be 24. Okay? Some general rules about factorials. Take n as being whichever number, so the factorial of n, by definition, is just n times n minus 1 times n minus 2 times blah, 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 until n minus a, in which a is whatever number, the whole thing factorial. All right? For example, what does this mean? Let's say that we are calculating the factorial of 100. So that would be 100 times 99 times 98 times 97 times 96 times 95 factorial. This part alone would continue these multiplications, all right? It will be 95 times 94 times 93, etc. until 1, okay? Another rule, if you have n factorial divided by n minus a factorial, that's going to be equal to n times n minus 1 times n minus 2 times etc. until n minus a plus 1. Again, what does this mean? Let's say that you have 100 factorial divided by 95 factorial. 100 factorial, you already know what it is this over here. If you would divide this by 95 factorial, this would cut out with that, so you are left with this bit over here. That's what this means. Okay? Knowing these general rules, let's now look at very typical type of questions that you will find in your exams, which is the number of arrangements that you will find in words composed out of letters, obviously. All right? For this, the next chapter may be of use as well, but from some of them at least, the instructions that you have here that I try to combine is going to be very useful. All right? So let's say that you want to calculate the total number of arrangements of the letters in a word in which all the letters are different. I use the word form. So you have F, O, R, and M, all of letters. All these letters are different. So the number of total arrangements, this is similar to the example I just gave with the markers, okay, is just 4 factorial. So in this case, it's just 24. So again, all letters different is just the number of the factorial of the number of letters. What if you have a word in which you have letters that are repeated? I use 11. 11 has 6 words, but 3 of them are repeated, which are the E's. How do you calculate the total number of arrangements? In this case, obviously, you'll have less number of arrangements as if you would if all the letters would be different. So how do you do that? That's just the total number of letters, factorial, divided by the number of times the letters are repeated. So in this case, the E's are repeated 3 times. So this would be 6 factorial divided by 3 factorial, which, applying this rule over here, would be just 6 times 5 times 4, that is 120. Okay? If you would just do 6 factorial, this would be a much bigger number. What if you have more than one group of repeated letters? I use the word mathematics over here. You have a total of 11 letters, but you have 3 sets of letters that are repeated. The M repeated twice, the A repeated twice, and the T's also repeated twice. So what do you do over here? Again, is a total number of letters, the factorial of that, divided by the number of times the letters are repeated in each group. So 2 factorial times 2 factorial times 2 factorial. I use the different colors to illustrate what each one corresponds to. All right? Anyway, as you can see there, it's a huge number, but much smaller than if the letters would be all different. Okay? Now, what if you have now groups of 2 or more letters together and next to each other? This is a typical question as well. All right? Calculate the number of arrangements that you have if you keep the letters, that's the example I use here, M, A, T, and H, so forming math together. So this is the steps that you need to follow. First, consider each group as a single letter and apply the rules above. So for the group, I'm going to over already this example. The group of letters in math is considered a single letter, and there are no longer repeated letters in mathematics. If I take math as a single letter, then I no longer have repeated letters because I have here the A, the M, and the T. If this are considered now one single letter, the ones that are left are unique, I mean, are not repeated, all right? So, applying the rule above, what is the total number of letters that you now have? I have the letter math, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8, all right, factorial. All right, I don't have any of these, so I don't have to worry about that. So I just have 8 different letters, that's 8 factorial. Step B, for each group, apply the rules above. Now, I'm going to focus on the group alone, which is the math, and I'm going to apply the rules above. So, again, all the letters are different within math, all right? So, applying the rules above, I will have 4 factorial for the group itself, okay? And then finally, multiply the value in A by the value in B. So, multiply, in this case, 8 factorial by 4 factorial. And I have this value over here. All right? Try to think of it yourself without focusing on the rule strictly. And if you take this as a letter, then you have all possible combinations of these 8 letters. And then you also have all the combinations that you may have inside the group itself. Okay? So, obviously, the number of arrangements is going to be the outcome of multiplying the total number of arrangements of the first one by the second one. And that's what you have over here. Now, the last example that I have is this. You have groups of 2 or more letters separated, not together, but separated by an arbitrary number of other letters. What do you have to do here? You have to do basically the negative of this. All right? So take a look at this. You have to use the rules 1, 2, 3, these over here, to calculate the total number of possible arrangements. Okay? The number of possible arrangements. Never mind about this stuff being separated or whatever. The number of all possible arrangements. Then on B, use rule 4 over here to calculate the number of arrangements in which they are together, not separated, but together. Okay? And then C, subtract the value in A by the value in B. If you want to calculate the number of ways in which letters are going to be separated, calculate first the number of ways they are together, and then subtract that to the total number of arrangements. Make sense? So using this example, which values we already know, for A, the total number of ways that I have for the number of all possible arrangements is this one over here. All right. For the word mathematics, it was this value over there. Let me just see one thing. Just to start with, I didn't explain this well over here. In this example, I'm using the word mathematics with the letters in math all separated. Okay, all separated. So first, get the total number of possible arrangements of the word mathematics. I'm using rule A. Then use rule 4 to calculate the number of arrangements in which they are together. We already did that over here, and we have here the value. So the number of ways in which they are separated is this minus that, giving this value over here.